Headless but unstoppable. Humanoid robot keeps fighting after losing its head at China's URKL Combat League. A dramatic robot combat match in China has taken the internet by storm after a humanoid robot continued fighting even after a head was ripped off during a high intensity bout. Now it's time to break down every angle of this story on our AI podcast.
I want you to picture a martial arts bout. You were sitting in the stands, the overhead lights are just glaring down, and the crowd is absolutely roaring.
Right.
And right in the center of the ring, you have two fighters just going at it. I mean, it is fierce. The pacing is completely relentless.
Oh, yeah, it's intense.
Yeah. And suddenly, one combatant finds an opening and launches this brutal, perfectly timed high kick straight to the other's head. And the impact is just sickening.
Ouch.
You watch as the fighter's head literally detaches. It is just hanging there, swinging loosely from the neck assembly. Now, in any normal fight, that is the definitive end, right?
The bell rings, medics rush in.
Exactly. But the headless fighter, he doesn't drop. He just keeps throwing punches. He keeps trying to close the distance.
Which is just wild to watch.
It really is. Eventually, his altered center of gravity causes him to stumble, he falls, and his own body weight completely crushes his severed head against the mat, and still, he tries to stand back up.
It sounds exactly like a scene ripped straight out of a big-budget sci-fi blockbuster. You know, you expect the director to yell cut at any moment.
But this isn't Hollywood, and it is definitely not CGI. This is real, raw, viral footage that you might have actually seen circulating recently. It's coming out of a robotics competition in China.
Yeah, it's been everywhere.
We have this massive stack of reports, technical specs, and raw footage from the world's first humanoid robot-free combat league. And our mission for this deep dive is to look past the sheer viral spectacle of a headless machine throwing punches.
Right. There's a lot more going on under the hood there.
There really is. We want to unpack exactly how far artificial intelligence and humanoid motion control have actually progressed, and what this brutal gladiatorial arena means for the future of intelligent machines. So, okay, let's unpack this, because we need a detailed play-by-play of this viral brawl to really understand the mechanics at play here.
Yeah, the details of the fight mechanics are crucial because they reveal the underlying engineering. So the event itself took place at a tournament called URKL.
URKL, right.
Yeah, which stands for the Ultimate Robot Knockout Legend. And in this specific match that ended up basically breaking the internet, we are looking at two highly advanced combatants. They're named White Eagle and Matador.
Great names.
Right. And for the first few minutes, it was a genuinely competitive, high-intensity bout. I mean, they were exchanging complex strikes, actively reading each other's movements, constantly adjusting their footing.
And then comes the climax. White Eagle finds that brief window of opportunity and just delivers this devastating high kick.
Yeah, right to the head.
It connects flawlessly with Matador's head, and the footage of this is incredibly wild to watch because the head doesn't just dent or spark. It partially tears right off the neck assembly.
Just completely detaches.
Yeah, it's dangling by what looks like some internal thick black wiring. But Matador doesn't power down, it doesn't freeze or go into a safe mode at all.
No, not at all.
Both machines just keep exchanging kicks and punches, like completely ignoring the catastrophic structural failure that just occurred on Matador's shoulders.
And that behavior is completely counterintuitive to how we normally interact with hardware. I mean, if your laptop sustains even a fraction of that kinetic shock, the motherboard cracks and it blue screens immediately.
Oh, for sure. It's done.
But Matador is actively trying to defend itself. It's launching counterattacks while its own head is swinging wildly from side to side, which, by the way, is violently throwing off its entire center of gravity with every single movement.
Right, and that center of gravity issue is what finally brings it down. The visual of the fall is so visceral because as Matador stumbles forward, it's unable to compensate for the swinging pendulum of its own head anymore, so it collapses.
It just couldn't stay upright.
Exactly. And as it hits the mat, the sheer weight of its own metal chassis comes down and crushes the already damaged head, completely severing those final wires. The head is just rolling away across the ring.
Which is crazy because under any traditional robotics paradigm, that severed connection should absolutely be the kill screen.
Right.
I mean, the primary sensory array is entirely gone.
Yeah. Which is why I'm struggling to understand the underlying logic of what happens next, because looking at the footage, Matador then tries to stand back up without a head.
Yeah, it really does.
Now, if I compare this to a human boxer, right? If a human takes a knockout blow, The central nervous system basically hits the reboot button. The brain shuts the body down to protect it. They are out cold.
Right, the lights are off.
Or, if they just get flashed, they might try to fight completely blind on pure instinct for a few seconds before their legs just give out. So, is Matador's headless continuation really a genuine display of AI resilience? Or are we just looking at a mechanical fluke?
A mechanical fleet.
Yeah, like maybe the physical off switch just didn't get hit by the kick and the robot is stuck in a mindless loop, just running a pre-programmed get-up routine until its battery finally dies.
Oh, I see what you mean. Well, what's fascinating here is that this was definitively not a glitch. And it certainly wasn't a mindless loop. No, it is a genuine, calculated display of computational resilience. When Madgore's head was severed, it obviously lost its vital sensory inputs. The primary vision processing and spatial tracking cameras are all located in that head assembly.
Right, it's totally blind.
Exactly. But the robot's core processor, which is located deeper down in the chassis, was still actively trying to solve the problem of its environment.
But wait, if its cameras are crushed, it's completely blind. How does a blind machine even know it is on the ground to begin with?
It does it through a digital version of proprioception.
Proprioception.
Yeah, so think about it like this. When you close your eyes, you still know exactly where your arms and legs are, right?
Sure.
Your muscles and your inner ear are constantly sending feedback to your brain about gravity and your body's position. The robot relies on something called inertial measurement units, or IMUs, which are built right into its torso and joints. These are basically microscopic gyroscopes and accelerometers. So even without any visual data, those IMUs were screaming to the core processor, hey, we are tilted 90 degrees relative to gravity.
Wow, okay, so it felt that it was sideways.
Exactly. And the underlying motion control system took that data and actively tried to recalculate its balance parameters on the fly to push back up against gravity.
That is mind-blowing.
It is. It only collapsed again because without the head assembly, it had lost too much physical mass and critical sensor data to successfully close the feedback loop required to maintain a dynamic standing balance.
So it wasn't a loop at all. It was actively rewriting its own internal physics engine in real time, basically realizing it was suddenly missing 15 pounds from its top half,
Yep.
and then trying to figure out how much torque the knee actuators needed to compensate. That is just incredible. And meanwhile, it's probably worth noting that White Eagle, having secured the knockout, immediately started celebrating in the ring.
Oh yeah, the dance.
Yeah. It executed a series of complex victory poses and these fluid dance moves, while officials had to literally run in and drag Matador's headless body away.
Right, and the balance and rapid recovery required to execute a fluid victory dance, or to try and stand up after losing your head that just isn't standard in robotics at all.
I would imagine not.
Most automated systems are incredibly brittle when it comes to unexpected physical variables. If you change a traditional robot's weight distribution by, say, ripping a heavy component off, its pre-programmed physics model breaks.
It just doesn't know what to do.
Exactly. It doesn't know how to adapt, so it just crashes. The level of adaptability we saw in that ring requires a very specific, highly engineered platform.
And here's where it gets really interesting, because both of these fighters, White Eagle and Matador, are actually built on the exact same base model.
Yes, they are.
It's called the Engine AI T800. It was introduced just last year by a Chinese robotics company. And they're clearly not hiding their pop culture influences here. It is literally named after the iconic Terminator character from the sci-fi franchise.
Naming your platform after the most famous killer robot in cinematic history is definitely a bold marketing strategy. But when you dig into the engineering specs, they are entirely backing it up.
They really are. When you watch the T800 move, you are basically watching an actual martial artist. It is not doing those stiff, robotic, wind-up punches we are used to seeing in older technology.
Not at all.
The capabilities listed in the engineering specs are wild. We're talking powerful punch combinations, high and low kicks, spinning roundhouse kicks, seamless kick-punch combos. It moves with a fluidity that is honestly a little unnerving to watch.
I agree. And to understand how it achieves that level of fluidity, you have to look at how Engine AI engineered the brain and the muscle of this machine to work in constant millisecond by millisecond tandem.
Right.
Humanoid movement is widely considered one of the hardest problems in mechanical engineering.
Yeah.
Walking on two legs is essentially just a highly controlled process of constantly falling forward and catching yourself before you hit the ground.
That's a great way to put it.
Now, take that incredibly delicate balancing act and add the massive kinetic force of a roundhouse kick to the equation.
Right. Because if I throw a heavy roundhouse kick and completely miss the target, The momentum of my own leg spins me completely off balance. My brain has to instantly tell my other leg to hop or brace so I don't just fall over.
And that is exactly the problem the engineers had to solve. To achieve the rapid recovery movements and dynamic balance corrections we saw in the ring, the T800 relies on a complex trinity of technologies.
Okay, what's the first one?
First, you have sophisticated motion control algorithms. Think of this as the raw math. Imagine trying to balance a heavy broom on the palm of your hand while someone is actively throwing rocks at the broom.
Okay, that sounds impossible.
While the hundreds of tiny, instantaneous micro-adjustments your hand makes to keep that broom from falling over. That is what the T800's motion control algorithm is doing 1,000 times a second, predicting exactly where the robot's center of mass is.
Okay, so the algorithm is the math keeping it upright. What are the other two pieces of the trinity?
Second, you have the AI decision-making systems. This is the tactical brain. It is analyzing the opponent, deciding when to throw a punch, when to block, or when to brace for an incoming impact.
Got it.
And third, you have the precision actuators.
The mechanical muscles.
Exactly. And these are far more advanced than just simple motors. These are highly complex joints that can snap into position with incredible torque and speed, but they also act as sensors.
Oh, I see.
The AI tactical brain tells the motion controller it wants to execute a high kick. The motion controller calculates the exact physics required to not fall over while swinging that leg. And the precision actuators physically execute the move, but they are constantly sending feedback back to the brain about physical resistance, joint angles, and gravity.
And that all happens instantly.
That entire conversation happens in milliseconds. That's the underlying mechanism of how a machine can try to dynamically correct its balance while its physical body is actively being destroyed.
The computational power required for that is just staggering. But this raises a huge question for me.
What's that?
Engineering a robot with real-time AI decision-making, sophisticated motion algorithms, and these hyper-expensive precision actuators, I mean, that has to cost an absolute fortune. We are talking about multi-million-dollar machines here.
Oh, easily.
And they are building them specifically to put them in a ring and have them kick each other's heads off. The economics of that makes zero sense if this is just for entertainment. So why go to all this trouble?
You have to look at the global ecosystem driving these advancements.
Yeah.
The entertainment value is really just the surface layer. This is so much bigger than just two robots fighting in a cage.
Which is why we need to dive into the leak itself. Looking closely at the source material regarding URKL, it becomes very clear this is not just some sideshow novelty act. They are actively promoting this as the world's first professional humanoid robot-free combat league.
Yes.
And the scale of this operation is massive.
It really is. For this inaugural competition, over 200 teams entered. And these aren't just, amateur hobbyists tinkering in a garage. We are looking at top-tier robotics engineers, university research labs, and AI developers from 10 different countries.
Wow, 10 countries?
Yeah, and they all had to navigate these rigorous online qualification rounds, which ultimately narrowed the field down to just 32 elite teams for the main tournament.
And the rules for the tournament are absolutely fascinating. We mentioned earlier that White Eagle and Matador are both built on the Engine AI T800 platform.
Right.
Every single team in the tournament is handed that identical base model. It is a strictly standardized platform, but once they have it, they have to transform it, right?
That's right.
They have to design custom armor plating, heavily tweak the internal software, and improve the mechanical performance to try and gain a competitive edge over the other team.
It is very similar to the philosophy behind Formula One racing.
Oh, that makes sense.
Yeah, where every team has to operate within incredibly strict technical parameters. But the true genius lies in the minute customizations. And you see that reflected heavily in the judging criteria.
Right, because it's not just about hitting hard.
No, if a team thinks they can just strap heavy steel plates to the robot's fist to make it punch harder, they will lose immediately. The judges are evaluating advanced engineering across several highly specific metrics.
What kind of metrics?
Teams are scored on their motion control, their dynamic balance and stability, the speed of their perception systems, how intelligent the AI decision-making is, structural durability, and overall combat performance. And they also heavily weigh power management.
Let's pause on power management for a second. Are we just talking about ensuring they put a big enough battery in the chassis so it doesn't die in round 2?
It goes far deeper than basic battery capacity. We're talking about managing digital exhaustion.
Digital exhaustion.
Yeah. When a robot throws a high-torque roundhouse kick, it draws a massive spike in electrical current. The copper coils in those precision actuators physically heat up.
Oh, I didn't even think about that.
Yeah, and if the knee actuator gets too hot, its electrical resistance changes. It experiences thermal throttling, meaning the motor behaves differently and becomes sluggish.
So it literally gets tired.
Essentially, yes.
Uh-huh.
So the AI isn't just deciding if it should punch it, it's actively calculating thermal load. The AI has to realize, hey, if I throw this 50-punch combination right now, my hip actuator will hit 85 degrees Celsius.
Wow.
Which would reduce my torque by 15% for the next 2 minutes, leaving me completely vulnerable to a takedown. So the development teams have to program the AI to literally manage its tactical stamina.
They are programming a digital physics engine that accounts for muscle fatigue in a machine. That is mind-blowing.
It's incredible engineering.
And the stakes for getting that code right are sky high. Looking ahead to the upcoming 2026 season, the schedule is already locked in. The qualifying rounds are set for July and August, with the championship finals happening later in the year.
And the payout is huge.
Yeah, the financial incentive is massive. The winning team gets a championship belt, sure, but they also take home a staggering 10 million yuan. That translates to roughly 1.44 million US dollars.
That prize pool makes it one of the absolute richest competitions in the entire field of humanoid robotics.
So what does this all mean? When you look at the identical multi-million-dollar base models being handed out, the incredibly specific engineering judging criteria, the focus on thermal throttling, and that massive cash prize... So they're giving away $1.5 million, but in return, they are getting 200 of the world's best engineering teams to solve edge case physics failures for free.
Yep.
URKL is essentially a massive crowdsourced research and development grant, just cleverly disguised as a gladiatorial sporting event.
If we connect this to the bigger picture, your assessment is spot on. It is crowdsourced R&D on steroids.
It's brilliant.
Think about the severe limitations of a sterile robotics lab. You can program $1 million prototype to walk on a treadmill or step over a wooden block in a controlled environment. But how do you safely test its ability to dynamically maintain its balance when a 200-pound object slams into its shoulder at 30 miles an hour?
You can't, not without intentionally destroying your own multi-million-dollar prototype over and over again.
Precisely the problem.
Yeah.
But by creating a professional, heavily funded combat league, the organizers are outsourcing all of that physical risk and all that innovation to 200 teams globally.
Wow.
Pushing these robots to their absolute breaking point in front of millions of viewers provides invaluable real-world data. Every single time a robot falls, every time an actuator overheats and throttles down, every time an AI miscalculates a block and takes a hit, mountains of telemetry data are recorded.
That's a lot of data.
It is arguably the fastest, most brutal way to rapidly improve robotic mobility, physical durability, and autonomous split-second decision-making.
It is the ultimate stress test. They are intentionally breaking them in the most spectacular ways possible to figure out exactly how to make them unbreakable.
Exactly.
Which brings us full circle to that incredible viral footage of Matador. What started out looking like a viral sci-fi video of a headless robot stubbornly throwing punches. I mean, it is actually a raw, unfiltered glimpse into the absolute cutting edge of AI resilience.
It really is.
Events like URKL are rapidly accelerating how modern robotic systems learn to operate and even dynamically adapt their own physics engines after sustaining catastrophic physical damage.
And this raises an important question about how these agile, incredibly resilient machines are going to shape the next generation of humanoid robots designed for everyday life.
Right, outside the ring.
Because the hyper-advanced technology being perfected in that fighting ring to keep a headless robot balanced, well, will eventually be the exact same technology that keeps a medical assistant robot from dropping a fragile patient if it accidentally trips over a rug in a hospital.
Oh, that makes total sense.
Yeah, it is the exact same AI decision-making and thermal management that will allow an autonomous vehicle to instantly recalculate its steering and braking physics if one of its tires violently blows out on the highway. The combat is just the crucible where the bugs are ironed out.
The combat is the crucible. I love that framework. And that leaves us with a final thought for you to chew on as we wrap up today. If developers are using combat sports to perfect an AI that can seamlessly adapt to losing a limb or a head in a matter of milliseconds, imagine applying this unkillable autonomous technology far outside the ring.
The possibilities are endless.
Picture deep space exploration, where a robotic rover takes catastrophic damage from a micrometeorite on a distant moon millions of miles away from any human repair team. Or imagine a rescue robot operating deep inside a collapsing, burning disaster zone where conditions are constantly changing.
It would be revolutionary.
If a machine can intelligently rewrite its own physical parameters, correct its balance on the fly, and stubbornly continue its mission while actively falling apart, well, where exactly is the line between a broken tool and a relentless artificial survivor? We started today watching a machine lose its head and keep fighting. The real question is what it's going to be fighting for tomorrow. Thank you for joining us on this deep dive. Keep questioning the world around you.
Okay, one question for you. If humanoid robots can continue fighting even after losing their heads, how close do you think we are to developing machines that can operate independently in dangerous real-world situations such as disaster rescue, military missions, or industrial accidents? Share your thoughts. Thanks.